And just continue on. The last equation that you need is back to equation 3. Okay? And here in this equation, the unknown is FAC. Right? So just move FABX to the other side of the equation. And since down here, using geometry, using this triangle, you found out what FABX is. So FAC equals FABX. That's it. Okay? So this analysis procedure is very, very straightforward, very logical. You use this equilibrium condition, right? Sum of forces equals 0, right? Using the two components, right? And knowing the direction of all your forces acting on this joint, right? You'll be able to figure out the unknown. Okay? Again, there are two equations, so at most, you can only have two unknowns for a joint. Okay? So this means that when you begin your analysis for a truss, you should pick a joint where there's no more than two unknowns. Okay? Otherwise, you won't be able to solve for it. Okay. Let's do an example. Let's plug in some numbers. Right? Okay. Let's use the same bridge. Okay, it's the same truss. Okay? And let's play with the numbers. So let's say this is 30-degree angle. Okay? And let's say this is 1 meter and 1 meter. Okay, so it's symmetrical. Okay? And I have this load, and let's say I apply 100 Newton load, okay, down the middle, okay, at joint C. Okay. And knowing that, I'd like you to calculate all the forces in the members. Okay? So, which means that I have 1, 2, 3, 4, 5. 5 members. So there are 5 unknowns I need to solve for. Okay? Using the joint method. So, let's do that. First thing you should do, draw a free body diagram for the entire truss. Okay, so let's do that here. Free body diagram for the whole thing. Okay? So this is not a joints method just yet, right? So it's just for the whole thing. So let's draw that. Label it A, B, C, and D. I have this load of 100 Newton. I have this right here. So I have this reaction force at D, reaction force at A, Y, R, A, X, and apply the equations, right, for this whole free body diagram, right? And this is a rigid body, right? So just like before, exact same thing. The result is RD equals 1/2 of the load, and that equals 50 Newton. RAY equals, again, 1/2 the load equals 50 Newton. Okay? And RAX equals 0. Okay? So that doesn't exist at all. Okay. So I've calculated these two reaction forces at these two end joints. Now I can begin my joints method analysis. Okay. Here I have 4 joints, A, B, C, and D. Question is, which joint should I begin? Which joint should I use, right, to begin my analysis? Right? The goal here, again, is to find out all the forces inside all the members. Keep in mind, we only have 2 equations for each joint. Okay? Some forces X equals 0 and some forces Y equals 0. This means that I can only have at most 2 unknowns for each joint. Okay? Say this joint right here, joint C. How many forces do you have? How many unknown forces do you have? Well, joint C, I have this load. Well, that's known, so that's okay. But at the same time, I have these three members, okay, coming in contact with joint C. So joint C is subject to 3 additional forces. So total there are 4 forces. Right? Of the 4, 3 are known. So that's not good. We don't have 3 equations. We only have 2 equations. So joint C is not good to begin with. But joint B? Well, joint B has 3 unknown forces also. FBC, FAB, and FBD. That's no good either. Joint A is a good joint. Because joint A is subject to 3 forces total. RA, okay, this is called RA, right? FAB and FAC. So 3 forces. Of the 3, 2 are unknown. So it's okay. So joint A is a good joint to start with. Okay. Now, from the previous discussion, you can figure out the directionless FAB and FAC. Okay? Decompose FAB this way. So FAB Y, FAB X. Okay. Now that I know this angle, 30 degrees, so I can look at this special triangle. Right? So the special triangle that's made up of these 3 guys. Right? They're a family that belong together. FAB Y, FAB X. I know this angle is 30 degrees. And this is a right triangle, which means that this is automatically 60 degrees. Okay? So, knowing this, the rest is just very straightforward. RA, I know, is 50 Newton. Okay. So, go ahead and apply the equation. I'm going to use the Y component first. Okay? Because I know RA, that's a known quantity. RA is in the Y direction. So, it's more convenient if I start out with the Y equation. So, I have my RA pointing up, so positive, and then negative of negative FABY, and that's it. So 0. Therefore, FABY equals RA, which is 50 newtons. Okay. Knowing FABY being 50 newtons, we can come back to this special triangle, which is this right here, right? To figure out FABX as well as FAB. Okay? So, geometry, right? So, the special triangle up there. You can use sine and cosine. Okay, so trigonometry. So, let's say if I use sine 30 degrees is opposite FABY over hypotenuse FAB. Therefore, FAB equals FABY over sine of 30. Sine of 30 is 0.5. Therefore, FABY 60 over 0.5. So that's 100 newtons. Okay? So, we solve for one of the unknowns. FAB equals 100 newtons. Okay. As soon as you've calculated an unknown, I want you to come back to this original picture, the original drawing, and write down the answer. FAB is 100. So, on this member AB, write down 100 Newton. Okay. and also indicate whether it's a compression or tension force. Okay? Knowing this direction of AB, alright? Just like what I've taught you before, using Newton's third law, right? We'll figure out this FAB actually represents a compression force. So that's how you indicate it. So 100C for compression. So this indicates that member AB is under a compression force of 100 Newton. Okay. And keep going. Alright, so now I've used sine 30. Let's say, can I use maybe cosine 30 to help me figure out this FABX? Sure. And so you can use cosine or you can use tangent, right? Tangent 30, right, to take care of these two guys. So let's do that. So tangent 30 equals FABY equals FABX. Therefore, FABX equals FABY, which is 50 over tangent of 30 degrees. Okay, getting crowded. Now I can crunch numbers. Right, so 50 divided by tangent of 30 degrees. It gives you 86.6 Newton. Okay, so put a box around the answer. It will help you visualize everything too. So FABX, you just found, okay, to be 86.6. Now, we come back to this sum of forces X equation. So, applied to the entire free body diagram, I have FAC minus FABX. Right? Only these two guys are in the X direction. That's all. Therefore, the unknown is FAC. FACX. And FABX, which is found from down here, from geometry, from the special triangle, to be 86.6. And that's all. That's the unknown. So FAC is 86.6 Newton. From using Newton's third law, knowing this FAC goes away from this joint, this means it's tension force. Right? So this means that this member AC is under tension. Okay, so that's how you indicate the results. And we just keep going to the next joint. So which joint?